All right, we're going to go ahead and continue with the Honors Pre-Calculus B semester exam review, starting with 67. So these two problems are asking us to write the complex number in polar form. So here is my complex number. So first I'm going to note that A is -6 root 3 and B is 6. So this is the the real part and the imaginary part. And so one of the formulas that I need to know is, first of all, if I go from a complex number in Cartesian form to polar form, this is the formula. That's theta right there. Okay. So both of these are thetas. So notice that you have an angle and a radius measure just like you would when you have polar coordinates. And the formulas that go along with this are as follows. Okay, so there's r, and then theta is still the same formula, except now instead of y you have b, and instead of x you have a. So those are the formulas I'm going to be using here. So first let's find r. So here you're going to have 36 times 3 plus 36. So I will have an all square root of 144, which is 12. Okay, and now, so let me just write my final answer down here. So in the end, -6 root 3 plus 6i, where I is the square root of -1, is equal to r cosine of, and now I need to find the angle for both sine and cosine. So I'm going to use the inverse tangent formula. Make both of them positive. So this is equivalent to tangent inverse of 1 over root 3, which if you look on your unit circle, tangent of pi over 6 is 1 over root 3. So tangent inverse of 1 over root 3 is pi over 6. But if you notice, the problem here is in quadrant 2. So the rule, if you will, for that is to do 180 or pi minus pi over 6, which will get you 5 pi over 6, and that is my angle that goes down here. Okay. Okay, so there's number 67. Let's continue with 68. Okay, so 68, we have 3 plus I root 3. So notice this is in quadrant 1. Okay. And I'm going to do the same thing here. A is 3, B is root 3. So R is square root of 3 squared plus root 3 squared. Notice how I don't have the I in this formula here, right? It's just the numbers. So here's R. So in the end I'll have 3 plus I root 3 equals R cosine of the angle plus sine of the angle. Okay, so now I need to find the angle. And this one is already in quadrant 1, so I won't have to do anything special. Okay, and if you look on your unit circle, it is pi over 6, which gives me, tangent inverse of root 3 over 3 is pi over 6, because tangent of pi over 6 is root 3 over 3. Okay, so this would be pi over 6. I believe they give their answer for this one in degrees, so I'll put it in degrees. Okay, but just know that's also pi over 6. So that's what goes down here. Okay, moving on to 69. Write the complex number in rectangular form. So now we're going the other way. So this is just actually just evaluating what we have here. Oops. Okay, so this is my r, this is my theta. So what I'm going to do here is literally just evaluate 6 cosine of 5 pi over 3 is 1/2. Okay, 5 pi over 3 is in the fourth quadrant. Okay, plus I sine of 5 pi over 3 will give me negative root 3 over 2. So I have 6 times each of these things. So I have 3 plus, minus 3i root 3. Okay. Okay, so there's 69. Let's continue to number 70. Same deal. There's my r, negative 2. So this becomes negative 2 times cosine of 7 pi. 7 pi is coterminal with pi. Okay, so cosine of 7 pi would be negative 1. Sine of 7 pi would therefore be 0. So this is literally what I have. So the answer is just 2. Again, because this here is 0. Whoops, 0. Okay, so all of that goes away. All right, let's look at number 71. Move right along here. All right, write your answers in polar form given the following. So we got quite a long problem here as far as a lot to write down. And we're going to use some properties here to simplify this a little bit. So one thing you need to remember is for this top part here, if you're multiplying complex numbers in polar form, what you're doing is you're multiplying the r values, but you are adding the angles. So what this top piece actually becomes is 3 times 4, which is 12, cosine of, so again this was 3 times 4, cosine of pi over 3 plus pi over 6, and then you have the same thing here. So I'm just going to write the top part here. So this is for the top. So you'd have 12, and if you add pi over 3 and pi over 6, you get pi over 2, which is actually going to make this problem a lot simpler. So again, we're just still dealing with the top here. So this will give me cosine of pi over 2 is 0, so this goes away. So I'll be left with 12i up top, because sine of pi over 2 is 1, so I have 1 times I times 12 is 12i. So that's the top there. And now I'm actually going to do something a little bit different here. So this is correct. This is 12i, but I'm actually going to leave the top as, this part here. And you'll see why in a second. Because if I leave it like this, there's actually another property for division. So now I'm going to take the bottom part and put that down here. So all of this was for the top. So now if I put the bottom part down here, it actually simplifies quite nicely. So for division with complex numbers in polar form, you divide the r values. So you have 12 divided by 6, which is 2. And you subtract the angle. So pi over 2 minus pi over 4. Okay. So I'll just go ahead and do that real quick. Pi over 2 minus pi over 4 is pi over 4. Okay. It's like 1/2 minus a quarter. That's a 4 right there. Okay. And because the question asks you to write your answers in polar form, you can actually leave your answer like that. Okay. So if you're wondering why I didn't take this route of using 12i all up top here, it's just kind of a nice way for this problem just to kind of make use of the division formula here, where if you have division of complex numbers in polar form, you divide the r's, subtract the angles, which is kind of what they were going for in this problem. Okay, so that's number 71. Let's continue with number 72. Got so we're raising all of this to the fourth. And this question is actually asking you to use what's known as de Moivre's. Let me write it a little bit farther down. De Moivre. Probably not doing the best job of pronouncing that. Okay, but that is de Moivre's theorem. Okay, he actually has some work in probability as well. So here, what de Moivre's theorem says is if you have something like this, a complex number in polar form, raising it to an exponent, all you have to do is raise the r to that exponent and multiply the angle by the exponent. So in other words, this becomes 3 to the fourth, and let me show you my parentheses right here, cosine of 4 times 55 degrees plus I sine of 4 times 55 degrees. 3 to the fourth is 81, so you have 81 cosine of 220 plus I sine of 220. Okay, and they say you can leave your answer in polar form. And that theorem actually is just an extension of the problem that we did on the previous page when we used this multiplication of adding angles. That's actually just an extension that brings about de Moivre's theorem. Okay. All right, let's continue with number 73. And I apologize if you hear breathing or something in the background. That's actually my dog walking around. So we are on 73. And they're asking us to find the coordinates r theta that are solutions to the following system. And they say that theta is between 0 and 360. Theta to the nearest tenth. Okay. So how I'm going to approach this one is I'm going to set these two equations equal to each other. Okay. I'm going to move everything onto one side. So I have this. And so this is a quadratic, so I'm going to have to end up factoring. But just as kind of a little, not really a trick, but a way to make it look simpler, I'm going to say let x equal cosine of theta. So now this becomes 3x squared plus 2x minus 1, which is a little bit more manageable. Not only do I get to skip writing cosine of theta, cosine of theta, cosine of theta over and over and over again, but it looks simpler on the eyes too. So I'm going to use factoring by grouping here. So two numbers that multiply to -3 and add to 2. Okay, that's what I'm looking for, so I'll continue this on the next page. So two numbers that, this is what I have right now. Let me just write this again. So two numbers that multiply to -3 and add to 2 are 3 and -1. So I'm going to write 3x minus 1x minus 1 equals 0. Okay, I'm going to group, hence where the name comes from, these together. I'm going to make this a plus minus, just so I can avoid any confusion with negatives. Okay, so all I did there is I just made the negative a plus negative, which you're allowed to do. Okay, GCF of the first two terms is 3x. GCF of the second term, or the number I should take out so I get a repetition, is -1. Okay, the x plus 1's go together, the 3x minus 1, minus 1 coming from here, go together. So this is my equation. So I get x equals -1 and x equals 1/3 if I solve those. But x was cosine. Right? So theta is going to be cosine inverse of -1, cosine inverse of 1/3. So notice that this one you can use a calculator. The problem is that there are multiple angles where cosine of that angle is -1, and cosine of another angle is 1/3. Okay. Now that we're restricted here, if you go back to the original part of the problem, for theta to be between 0 and 360. So keep that in mind. Okay. So for this first one down here, cosine inverse of -1 is actually just going to be 180. So let's call this theta 1, theta 2. So theta 1, there's going to be one answer, 180 degrees, because theta is restricted between 0 and 360. We'll say for theta 2, though, okay, if you use your calculator, you'll see that cosine inverse of 1/3 is 70.5 degrees, which is an acute angle in quadrant 1. Okay, but there is another angle in quadrant 4, so we'll call that theta 3, that if I do 360 degrees minus this angle, I will get the third answer, which is 289.5 degrees. And you can check that. If you do cosine of 289.5, you should get 1/3. So again, how I got that is I just kind of thought about, if I have, here's the cosine inverse of -1 is 180. This is like theta 1. This is just kind of a simple way to think about it. Theta 2 is somewhere up here, right? And then cosine will give me positive numbers here and here. So how do I get the other point down here that will give me the same angle? Well, if you look at it, I can do 360 degrees minus that angle here, okay? And that will give me the third one. So that's why I did 360 degrees minus this guy to get the third answer, okay? And then just to put it all together, your final answers, let me just write them cleanly, will be, so we had, let me write them all out here. So we had 180 degrees, these were the angles. Okay. And then to get the R values, you can either choose the first equation and the second equation, just plug in theta. Okay, so if you do that, I believe I chose the first one. So if you plug in 180, 70.5, 289.5, you'll find all the R values. So when you do that, your final answers, you'll get 2 is associated with -2. 70.5 is associated with 0.67 and 0.67 here. So those are your final answers for number 73, okay? And we'll pick up with this in the next session. Thanks for watching.